All right, good morning, good evening, maybe good afternoon. I'm just doing a first audio test. Please, if you could confirm that you can hear me well, please. I'm also sharing my webcam and my screen. If you please could send me a message using the chat option that you have on your webinar panel, I'll appreciate that. All right, thank you both. Thank you, Jaime. We have maybe 2 or 3 minutes remaining yet, and just in 2 minutes we'll start with the presentation. All right, perfect. So good morning, welcome to this third webinar about the Cype workflow, or the open Beam tools that are part of this workflow proposed by Cype and the Beam Server Center platform. My name is Afonso Solac. I'm civil engineer and I work for the Department of Software Development of Cype. This is my second webinar during this week. Maybe some of you have been on our first webinar when we have been talking about Cype architecture, okay, the 3D modeling tool that Cype just released 2 months ago, okay? So yesterday, or I don't remember if it was yesterday or on Tuesday, my colleague Davi have been talking about the MIP solutions that we have at Cype Suite. So building facilities projects, so the software to calculate and develop projects of building facilities, okay? Today we'll be talking about a little bit of the project coordination, or the BIM coordination. So here we can have a scenario that is very popular in many projects. That is, we have different models, different disciplines, different people, and then we must put it together and generate and consolidate our project in a unique project, or in a unique model, or in actually the final model that we will have to represent this building that we will be constructing, okay? So a very easy example to understand could be, for example, this image that you see in my screen. So first, an architectural model created with one software, Then we can have a structural model based on this geometry, based on this first architectural model, and then the building facilities that were calculated using the spaces, the HVAC zones that were also modeled firstly on the architectural model. So now we have to combine it. Of course, in some cases, we will have a lot of building facilities, not just one model. This is just an image to try to explain this situation. And in the case of the Beam Server Center platform, we will have different IFC files. So one IFC to the structural model, one to the HVAC system, another one to the plumbing facilities, then another one to electrical facilities, and so on. Okay, so today we will be trying to explain how a BIM manager or a BIM coordinator could coordinate all this situation and then look for some clashes or some incompatibilities that we can have between these IFC files. Okay. Once we consolidate this model, as a next step could be the generation of the view of quantities and the quantities takeoffs of these models. So from the quantities, from those geometries that are in our models, we can calculate how much our building could cost. So we have tools for that. During this presentation, I will not explain everything about both softwares, both tools that we'll see today, because actually we don't have too many time for that. But the idea is to show the workflow that you can use and a little bit about these tools. Okay. So closing this this presentation, this little scheme, just to remember, on the first presentation we have been talking about Cype architecture. Okay, so you also can watch again this seminar just going to the Beam Server Center blog, so blog.beamserver.center, and coming here to the webinar gallery. And inside of this gallery, you have a lot of seminars, the last webinars that we have been doing. And this one was the first webinar about Cype architecture and the connection of Cype architecture with Strube's Cype 3D, a software for structural calculation. Okay, this presentation is going to be here during the next days on this platform, available on this blog too. Okay, so we have been talking about Cype architecture. Davi have been talking about some building facilities calculation software, and today we will use two softwares. We use two tools. So one of them it's called Open BIM Model Checker. So we'll check our model. We'll run some analysis to manage the issues of this model. And then once this model is finished, it's consolidated, we can go to another application and generate the view of quantities using, in this case, Open BIM Quantities for that purpose. Okay, so the idea is quite simple. Here, this is one model. Actually, I am on Cype architecture again. Okay, so let's suppose that in this case, I am the architect. I have been doing this project. Then using the Beam Server Center tools, I exported this first IFC file with this architectural model to my team. They have been working on their disciplines, and they also sent the information from their disciplines to the Beam Server Center platform, to the same folder that we have been working together. And after that, I updated my project, and now I can see the information that these colleagues sent to the project inside of Cype architecture. So that idea, it's I use Cype architecture as an example, but if you open on CypeCAD or Cype Plumbing or Acrobat by Cype, all the other softwares of our workflow will work like that. So you can also open the other files sent by your colleagues that are working the same projects. In this case, using the view systems of Cype architecture, I created actually here 4 3D views. One of them is the generic 3D view, general view. So actually it's the view that I used to generate this model. So it was my work view. Then I created a second view duplicating this 3D view that I called 3D with all IFCs. Actually here, if I deactivate these layers, we can see all the disciplines, all the other IFCs that my colleagues have been working and sent me before. Okay, so here we can see the plumbing facilities, some heating facilities here, some heating equipment to the plumbing facilities. Then we can see actually some suspended ceilings that were created by another colleague. Here we can see some electrical facilities. Okay, so actually it's a quite complete model. It's not 100% complete yet, but it's in advanced stage. So I think it's a good example, and we can try to generate some, try to coordinate this project. Just showing here, I created another layer, or sorry, another view that I called the 3D with the structural project, just the structural project. Okay, I am the architect, but I can see the results of this civil engineer that sent me the structural model, and I can see that it fits on my project. And I have another combination of files here that are just the MEP facilities in this case. Okay, so this kind of visual analysis that we have been doing using these layers can be done on other softwares of Cype. But here we cannot change any information that is not our own information. So this information from the plumbing piping system, I cannot change here. My colleague that made it should change that. So I have to send a message or try to contact this colleague and say, hey, these pipings don't fit on my project. You have to change it. You have to move it. You have to delete it. Watch out. Maybe you have a bin or a column or a slab here. So I must choose I have to communicate these issues with my colleagues, and I cannot do it using just Cype architecture or any other software that we have to the design process inside of BIM Service Center. To do that, we have this application that I have been talking, Open BIM Model Checker. Okay, so actually I will share with you the link to this application on the chat that you have on webinar. Okay, so then you can access this tool too. And I also have this application open on my computer, and actually I am synchronized and connected to the same project using these tools here of BIM Service Center. And I selected some of these IFC files, not all of them, to show here inside of Open BIM Model Checker. Okay, so Open BIM Model Checker, actually it's quite easy to understand. Here on the left side, we have a similar panel to display the different layers of information that we can have in our project. Actually here we are talking about different type of information. So we are talking about the 3D information, the IFC files here, but we can also see that some of the disciplines, some of the models that we have here, they have also this little button here that we can open, and sometimes we can see some results. In this case, for example, to the structural model, we have the results to some deformed shapes, the analytical model. Here on the plumbing facilities, you can see some results too. Okay, so it depends on the information that my colleague sent to this folder that we have in common at BIM Service Center. I can see that some results here too. Okay, the information here is classified in 3 ways. So we can represent the information by floors. Okay, we can also represent by models. It means architecture, structural, plumbing facilities, HVAC system, or by categories. So here we can have beams, columns, joists, slabs, windows. So here we can activate and deactivate the information using these 3 type of filters, let's say that. Okay, so the first thing that we can do with Open BIM Model Checker is to visualize the model. Okay, so that could be useful as a IFC viewer. So this is the first use of the software. As you can see here, the structural model is in brown. The slabs are brown, but we can see some layers that are very colorful. Maybe here it's going to be easier to see. Let's go there. So these layers are actually some results of the analytical model that was created with Cype. So here we have the structure, but we can see the lines of the results. When we put the mouse over these elements, we can read the information about each element. So here you can just inspect the model and read the information that is associated to this IFC element, and just putting the mouse over it. Okay, I cannot here. If you see, we can deactivate this information. Let's deactivate everything. Now we have just actually the beam model of the structural the structure. Okay, as if we go here, we can see also the joists here and the beams. Okay. Of course, here we can do this the same. We have the same tools that we have in the other softwares. So we, for example, here a section, or maybe using this one is going to be better, and use this key to move the section and try to find a good position to inspect something. For example, I can see here. I can see here that the size of the elements here are not a problem. There is no other element that is in the same place, so probably it's okay. Okay, and so this is the display view. Okay, so we can activate and deactivate these layers here, and then we probably will have some issues. As I said before, maybe some systems must be moved or must be changed, and these issues can be informed using this tab here. So the issues tab. Okay, actually this issues tab, it's going to be a list of issues, but we'll create the issues using this little menu here, the first menu that we have on the top toolbar. Okay, so I'll just create a new issue. I'll say that a title and a description for that. So, hey, please check those pipes, please. Okay, so, and then you can put some smile face here. It's nice in these days of working from home. I will accept that. Okay, then I will select which elements are where we have this issue. So which elements are related to this problem. Let's suppose that is this pipe here and this slab here and maybe this bin here, whatever. You can select many elements. Once you select that, you just have to click on with the right click of your right button of your mouse, and the issue will be created. So we will have a print screen of this issue. The elements will change color, so it's going to be this red color. You know that these are the related elements to this issue, and you have a status. Could be to solve or solve it. It's the way that you have to control that these issues were updated in the future. Okay, you can also then change this image. You can find another angle. Or activate and deactivate any other layer and do this picture again. You can also change your description here. And an interesting point is this part here, the elements. So here we have 3 elements, one from the category pipes, another one from the category floor slabs, and another one from the category beams, and the references of these tabs. In this case, I'm the author of both projects, the structural and plumbing facility project. So my name is here. Okay, the idea here is you can have different authors, and when we send this file created on Open Beam Model Checker again to Beam Server Center, these guys here will be notified in a specific place for that we have on the platform, also on the mobile phone, and we'll be notified that they have this problem, and they can see these informations describe it with a picture, and also in their beam models, highlighted on their beam models, so they can easily find these problems and discuss how to solve this issue. Okay, so this is a kind of manual way to inform a problem to someone of our team. We're not using yet an automatic system to find where are the problems, but with these systems we are trying to communicate with with our team in a beam way. Okay, so here we don't have to send a WhatsApp or maybe send an email or try to print screen something and then send in a Dropbox file. So here you just have to select on your own beam model and send it again to the platform. Okay, when we send that, I'll show you here. Let me open this project that I have here on the platform. Let me see if we have it here. So here, my projects. Let me show you how you can see that information. We'll look for that project in my gallery. Just a second. So here I have this project. This project was made by a group of persons. Let's open it. People. Sorry about my connection. Actually, this is a 1 GB project. It's a project that is very complete. So there's a lot of information here. Let's open it. Okay, so this is gonna be the dashboard. Maybe you are already familiar with this dashboard where we can see the 3D model and the last changes. And then we can have a place where we can create our work team, add other participants to this project. We can see the history of the project. Here we can see the files. So it's interesting to see the files because you can see these different layers of information, different IFC files here on the platform too. So here you can see, actually we have, I don't know, 20 or 24, 25 different files here, okay? And in this tab, issues and requirements, you can see those issues that were sent by someone that used OpenBeam Model Checker to notify another participant of the project. So we have two types. So we have issues. So issues are exactly this kind of situation that was my example. Just information exported directly from here from OpenBeam Model Checker. And then we have requirements. What are these requirements? They are some recommendations or some requirements, as the name say, that the software automatically create. For example, when we add electrical, for example, a TV or I don't know, a microwave or any other electrical equipment on our beam model, the system will say that we must add a socket, a plug socket, when we go to the electrical software or the software to electrical calculation. So this kind of requirements that are automatic, they are classified and they are placed here on the requirements section, okay? And the issues are here. These issues, when we click on that, so these are pending. So this was issued in another moment with another file of OpenBeam Model Checker that I requested to someone. This person was Carlos. Carlos was the manager of the plumbing calculation. So I asked him to please move the box because the box is colliding with the footings of our structure. Okay, so we can see this information here on the platform too. Once Carlos changed this information, we will update our models, and then I can come here and, for example, just check that this issue was solved. Okay, I can do this here directly on the platform, or we can use the update the information and change the status here inside of OpenBeam Model Checker. We have both options to how can I say, to resolve this checklist of issues that we'll have on our project. Okay, I see that we have a question here, just a second. Okay, Muhammad is asking us if the software language is customized, if we can change the software language. The softwares are available in different languages. So we are using the English version here. And for OpenBIM model checker, we can see here we have the Catalan, English, French, Italian, Portuguese, and Spanish version. I'm sorry about my example because this example was created during an event in Latin America. So some files that you can see, for example, like here, the name of the files are in Spanish or maybe in Portuguese, but it's just the name that the name of the files that I created before. It's not the translation of the software here. Okay, so this is a name that I created before. It means architecture in Portuguese in this case. Okay, so don't worry about that. This is just the name of these IFCs that that we use it as an example. Okay. All right. So these are the issue systems that we have here on OpenBIM model checker, but it's impossible to just find all the problems that we can have with all this information just looking to the project. It's too complicated to do that because we have too many variables here to think about it. So then we have the third step, the clash detection tab. So maybe this is the most interesting part of this software, okay? Because here, what we will do is the famous clash detection analysis. We will put two or more elements, two or more layers of information, two or more IFCs in this case, and we will try to find where these IFCs collide. So that's maybe the best example is, for example, plumbing and structural. How we do that? It's quite simple. We'll create here a new file combination. Okay, so first I'll create this new file combination. The software will read which files that we have in this project. For example, we have a file with the structural model, and then we have another file with the plumbing facilities. So this is the sanitary facilities actually in our model. Okay. Inside of our structural model, we have different categories. So we have beams, columns, floors, foundations, openings, walls, different IFC entities that are inside of this model. Maybe I just want to run a model to be, an analysis to be a little bit faster, including just maybe the beams and the columns and the slabs, and don't activating, for example, the foundations, don't including the foundations, because I'm sure that we don't have any problem on the foundations. So we can personalize this selection, because actually if we selected everything or all the files and all the categories, this analysis would be very complex, and we will lose a lot of time, because probably in some of them we will never have a collision, but the time to verify that we don't have a clash would be very long, and we wait too much to run this analysis. Okay, so in this example, I will run a combination of structural and plumbing facilities. On the plumbing facilities, I will activate the pipes and the hatches, and I will accept that. It seems that we don't have anything yet. Okay, actually we didn't run the analysis yet. We are just creating a file combination. Actually, we can create a list of file combinations, just thinking on where we could probably have problems, and then when we have more time, just come here and press the play button to detect the clashes of this combination. So that's a smart way to first generate the file combinations, the list of files combinations, and then run these combinations. Okay, I will quit this section here, and actually I'll come back to the display, and I'll do something similar to be easier to understand. I will deactivate some layers. For example, here I will leave just the layers that we are analyzing on this clash detection analysis. Okay, so I'll deactivate some information that I'm sure that we will not use, just to have something easier to understand. Okay, so now we have just the structural model and the plumbing facilities, or the sanitary system model. Okay, so we'll come back here to the clash detection, and now I will run this analysis, okay? So as you can see, we have here a process that was initiated. It's trying to find combine element to element and try to find where they collide, okay? As I said before, if we select too much files or too much categories, this bar would be long, so we will have to wait a little bit because it's going to be an analysis too complex, okay? Let's wait a little bit to see what we have here on this situation, okay? Actually, let me see something here just to share with you on our project here. The same project, maybe this is a point, maybe you are new here on the Bean Server Center, maybe you don't know about that. Here on the Bean Server Center platform, you can also visualize the project, okay? So here you have a 3D viewer. You don't have to have any software to visualize a software project here, okay? It's just an online viewer. And this point here where you have the name of the project, you can click here, and here you have the other layers of the project. Actually, by default, just the architectural layer, a simple, simplified architectural model is represented by default here. Then you can activate all the other layers of the project here. So for example, just putting the architectural model on transparent, for example, visible but on transparent, and activating, for example, the structural model, you can see this information here directly on your browser. Okay, you maybe in some situations it's useful because maybe you don't have your computer or don't have a software on your computer. You can just come here to the Bean Server Center platform and take a look on that. And you can also create here some sections as we created on the softwares. Okay, so here we can create the sections. Okay, so here, for example, you can create any section here. It's the same way that we created before on OpenBean Model Checker. Okay, let's see if our clash detection is running here, so it's gonna finish in some time. Could be a lot of models here, probably because we have a very detailed structural model in this case. I'll wait that, and I think this is a good example. I will leave it working, and maybe when we finish the other part of the presentation, this analysis will be finished. Okay. Actually, let me do something here just to be sure that's gonna finish it, because I exported this model with too many information yesterday, so I will export it again just to show you how we can do that. So here we have let me open Cype. It's a good opportunity to show a little bit how the information is going from one software to another. So I will open Cype. Cype wasn't part of this presentation during this cycle, but you have a lot of webinars about Cype here on our webinar gallery. Okay, and this structure was calculated here before. And let me send this model with less information, because it was with too many information and this analysis will be too long. Okay, so actually here we have the same model. We can see the model in the 3D view here. Okay, let's wait. So this is the 3D model. Actually, we are with the materials filter. Okay, and I will come here to the Bean Server Center menu, and I'll export it. And these points here, the lattices are too many lattices and joists. So this information will make our model more precise, but also the analysis would be longer. So I will overwrite this file. I will send this information to Bean Server Center again. Just let's wait this little bar here that is loading. So it was exported. So with the name is structure.ifc, and then here on OpenB Model Checker we can update the file. Okay, so I will update the file. This is a nice way to show how the workflow itself works. So it's just using these little buttons here. Here in Cype architecture, you can see that the button, it's going to be flashing too, because it's a notification that we have updates in our project. So let's wait the list of IFC models that we have in this project, or the IFC layers that we have in this project. So we could also change the project, change the folder, and look for a second version of our project, or maybe try to connect to a second project. Okay, so here you can see we have all these files here, and this one that we changed it was this one made with Cypecat. It was selected before, synchronized here, this name, okay, this description, and you can see here that we have changes. So yeah, we can see here that we have changes, and then I will just accept and import the file with these changes to OpenB Model Checker. Okay, then you see that the lattices and the joists will not be visible here. We will see just a kind of rectangular prisma with the geometry with this slab, but not all the details of the elements. Okay, so it's a smart way to run this kind of analysis. Okay, we don't have too much details for that. Okay, let me see that we have a little question here. Just a second. Can we delete items from the IFC file to string line IFC file? Yeah, Paul, we can delete all the information that is created by us. So my own information I can change, okay? But we cannot delete the information from a team colleague that was sent by him, okay? Except if we are there are some roles here on the Beam Server Center platform. So the work team have different roles. In some of them, the higher roles, we can delete the IFC files, not part of these IFC files. Okay, so the information is or the models are a responsibility of each member of the project. Okay, and just this person can change these models. Okay, as you can see here in this project, I'm the owner. Then we have a lot of guests, and the role guest cannot change or delete anything, but the owner can delete one of these files. Okay, so we can. That's the only way to change information that is not our information on the system. Okay, so here on Model Checker, on OpenB Model Checker, we can select. We can consult this information, but I cannot delete one being created at Cypecat or one pipe created at Cype Plumbing, because I'm not on that software that designed this bean or this pipe, and I'm not the owner of this discipline, okay, or this specific project. Okay, I don't know if I answer your questions. If it's too confused, please you can complement using the chat. Okay, as you can see here, the update was finished, and we cannot see anymore the joists and the lattices here. So it is just a reference. It's a panel, a floor slab with a reference, description, material type, and diff. Okay, but it's also with this information, we can do our analysis, because we just have to know if in this case the pipes are clashing with these elements. So now we have here the same file combinations already created. If we go here, in sometimes when we reduce the type and the quantity of information of our model, sometimes the categories could be excluded from our analysis. In this case, doesn't matter, because we are actually using one category that is called floor slab. Okay, so we have it here, and just accept. And now I will run this analysis. And now the analysis is much faster. As you can see here, the information, so the analysis is done. So with that information was sufficiently, we have sufficient information to generate this analysis, okay? This analysis found, let's see here, 263 different possibly clashes. Why? Because some of them maybe are clashes that we can assume that we have this kind of problem, or it's not actually a problem. It's way that this model was just a way that the way that this model was generated, and the system is very sensible. So maybe some millimeters of a tube that is some millimeters in contact with a beam could be classified automatically or by default by the program as a clash, but sometimes it's not actually a clash. Depends on the effort that we had when we created these models. Okay, of course, when we develop the models, we know where the other disciplines are. We will try to create our work, our model, thinking on the model that was created before, trying to avoid any other elements, and then reduce the number of clashes here. Okay, so this one that was selected here, it's a very good example. It's a clash. This is just a code of the pipe versus the code of the beam. So the beam 4 with this name and the pipe with this code. It was a clash between those elements. So the category is pipes versus beams. Okay, and it's highlighted here which elements are where it's the clash here. Okay, so with these buttons here, we can select just the elements that are related to this clash. Okay, so these elements here, and we can use this button here to generate an issue based on this clash. Okay, so this was the manual way to inform something to someone of our team, and this way it's a way to identify where are the problems, and then we can inform using an issue our team. Okay, so I will create here generate issues. At least one element but must be selected. Okay, so we must select actually which clashes from this list are really related to the issue that we wanna send to Beam Server Center. Okay, so I'll select this guy here, and now I will generate the issue. What issues are going to be generated? Do you want to continue? Yes, I would like to continue. The issues was generated. If we come back to the issues here, a new issue was created automatically here with a code that was clash the code of the pipe versus the beam, and it's yet to solve. Okay, in this case we don't have an image, but we can add an image here manually if you want. Just don't remember where was the button here. I think it's this button here. Yep, so here this little button here, capture the current view, and we can add this, and we can also describe it. Hey, let's see who is the author. Oh, so here the author of the blue element is Afonso. It was me. And the purple element is also Afonso. Okay, could be Carlos or could be Paul. Okay, and then let's suppose that the right movement here is actually move the pipe and not change the beam. Okay, the beam must be in this place. So I will say just to this part here, just this author, he must review his part on the project. So hey, Afonso, please move that. Move that pipe to the side. We can move the beam. Okay, so some information that you can add here just to complement the image and the model itself. Okay, you can also create some annotations here, adding a line, an arrow, a quadrilateral. You can also add some measure or use these annotations tools here to complement the image that you have here. Okay, you can also change for monochrome, or maybe you can just show part of the model. You can hide information just clicking with the right button of your mouse. Hide some information that does not matter to this issue. For example, this issue doesn't matter. This pipes, okay, and then just updating the current view. You can then create this issue and send it to Beam Server Center. I will export that in some minutes. When we finish the presentation, we'll come back and see these issues on Beam Server Center platform. Before doing that, it's interesting to say that I can have my OpenBeam model checker file as architect, or as Beam coordinator, or as project manager. But if I would the civil engineering work with CypeCAD during the structural calculations, I can also have a second file of OpenBeam model checker with my issues, okay? And then a third colleague that is working on the project can also have a third file of OpenBeam model checker with different issues, because actually this is just the app to send and receive issues, my issues, okay? And not so we can have a different or a lot of OpenBeam model checker files inside of this this Beam Server Center project, okay? And when we export this file, we are creating a file with a name, with extension .ifc. So I will create that these are the issues identified. I'm sorry, I don't remember in English if it's right here, but it doesn't matter. By Afonso, for example, one example. And then I will accept that. And I will export. A local file was saved as any other project that we have, any other software that we have here in the system proposed by Cype. Okay, I'll save that. Let's wait. It's at this moment, Beam Server Center sync would send this information to the project. Okay. Let's change a little bit the theme of our presentation. Let's suppose that we have been doing this step, or this phase of consolidation of our project. We created a lot of issues. Our colleagues have been changing their projects. All the issues are solved. We made it with all the disciplines that we have, and the project is perfect. Okay, so we consolidated our project. The Beam model, it's almost the digital twin of our construction. Okay, so we are in the almost in the end of our project. Actually, we are in the end of the phase of modeling our project. Now we must start the phase of documentation, or generating all the documents that we have in our project. One of these documents is the quantities takeoff and the view of quantities. Okay, so for that we'll have something very similar. In this case, we will use another tool called OpenBeam Quantities. So the name it's easy to understand what this software do. So adopting the information that was implemented on the project by our colleagues using other tools, we will extract the quantities and develop the view of quantities. Okay, so for that, let me open the OpenBeam Quantities here. Okay, OpenBeam Quantities. Oh, sorry, I opened the Portuguese version. Let me open the English version. Just a second. I think this one is gonna be this is the English version. Let me see that we have some questions here. Just a second. Thank you, Paul. Thank you. I appreciate that you understood my explanation before. Okay, so this is OpenBeam Quantities. We are using the version 2021A. Okay, I'm logging in here on Beam Server with my account of Beam Server Center, as the other softwares that we presented during these days. Okay, so here I create a new file. So this is going to be a new file of OpenBeam Quantities, and this file will be capable of generate a new IFC file after that, as we made with Cype architecture, model checker, Cype fire, Cype plumbing. Okay, so it's going to be my view of quantities the project, I think the project, it was called Intro Open Bean or something like that. So this is just a name. I will accept that. And then I will select the file on my account on Bean Server Center, or on the list of projects that I have on my account, and just the projects that are synchronized with this computer that I'm working now. So I use the Bean Server Center sync to do that. So you have in this computer now 18 software projects that are synchronized here. Most of my projects are not on this computer, are just on Bean Server Center on the cloud. But here with this check, these projects are here on this computer. Okay, so it's a way to save space on my computer, just maintaining these backups on the cloud. Okay, so here I have the list. Using the spacebar, we can look for some information here. For example, the project was called Intro Bean. Okay, so I will select this project, accept, and let's wait. Let's wait a little bit just to synchronize with the same project. Okay. As you can see here, the menu here, it's quite similar to that menu that we have been working before with OpenBean Model Checker. It's going to be a list of IFCs that I wish to import to this step that I will do now. This step that is the generation of the view of quantities. Okay, maybe I don't have to import the issues, for example, created by OpenBean Model Checker, or maybe I will not import some information that does not need a view of quantities. Okay, so here I have a lot of files. I'll import just some of them to be a little bit faster. For example, I will import the same structural model that we created with Cype. Okay, I'll import here the architectural model that we created before. I could import, for example, here the steering ramps that were created in a separate model. And for example, here some Cype plumbing building facilities or plumbing facilities. Some here, for example, let's see something that is interesting. As you can see here, the OpenBean Model Checker, actually, let's organize it. We have here some files that were generated by OpenBean Model Checker. Between them, this is the file that we've just created before, the issues identified by Afonso Solak. So I can also open these issues here, but it doesn't matter to budget purposes. So I will not import these issues here. Okay. Okay. I think if with these examples, it's okay. I will just accept that, and let's wait the software import these IFCs to OpenBean quantities. Okay, so it's importing the floors, the spaces, all the models. So the process is finished, and now the work environment have been prepared. Okay, here we can activate the different layers that we have in our Bean model. Okay, let me move this black bar of GoToWebinar here. So it's quite similar to the other softwares. Okay, we have a 3D environment that we can use to inspect the model. We can activate and deactivate the layers that we imported. So in this case, 4 layers. Okay, and we can click on the elements here, and each element from our Bean model is listed on this project menu here. Okay, so this project menu is organized adopting the classification proposed by the IFC format. So the classification, the structure of the IFC format proposed by Building Smart. So inside of this format or this classification system, we have some entities. So these entities are standard. So the IFC door, it's always called IFC door. The IFC column, it's always called IFC column. Okay. When you export the models from Cype, from Cype Architecture, IFC Builder, Autodesk Revit, Allplan, ArchiCAD, SketchUp, and export using the IFC format, you can decide in which entity each element will be located. Okay, so we can say that column, it's a column exporting prismatic volume as a IFC column. Okay, for example. So we use the same structure here. So if you are familiar with the IFC format, you see that and you know what is that. Okay, it's very easy to identify that. And when we click in an element here, for example, this little wall, we can see in the list where this wall is located. So this wall was located inside of the category or the entity IFC wall. Has a name that is called parapeito, that in Portuguese it means a railing, for example, or something like that. Okay, and here we can see other parameters of this bin entity or this bin element. So it's part of the IFC wall, has a name, a global ID. Okay, here we have some presets, for example, the preset that identifies that if this wall it's external or internal, it's set as false. Okay, and the most important part, the base quantities or the information related to the quantities of this wall. Okay, so here we can see that we have some information that automatically was how can I say, was not imported, but it's part of the element. Okay, so the width, the gross side area, and the net side area. Okay, here we can see this information. If we click on other elements, we can see different parameters. Okay, depending on the element. So here we can see on this window, it's just a simple model. Okay, we could have different parameters here. For example, we have the height. In the wall, we don't have the height. We have the gross area. Okay, so these parameters depends on the elements that we are importing. Okay. The idea here is quite simple. For each element that we have on our model, in our bin model, we will associate an information, an economic information, and an information that is associated to our budget that could come from a cost database. Okay, so to do that, we must have three main things. First, the quantities that come from our bin model. This information we have, and we add this information when we imported the model from bin server center. The second point is importing a cost database. So we must have prices for the items that we will have in our bill of quantities. Okay, so for that we can import we can create and import databases here on the software. We'll just do an example how to import a file here. So here we can create a new cost database. Yeah, I'll create a new cost database, and we can edit a cost database. Just a second here. Here, yeah, here. This little button here actually is just to change the directory where the databases will be saved. Okay, these buttons here are used to create or import new databases. Okay, so when we add a new database, for example, it's going to be a cost data of today, some name. Okay, when we can start editing this information and create a structure with chapters, items, creating with all the resources and prices that we will add in our cost database. So if you don't have a cost database, you can create your own cost database using this tool here. Okay, you can create here at first chapter with a name, chapter 1. Okay, and then inside of the chapter you can add an item. This item could have a code, a unit, if it's labor, machinery, materials, the price, text. Okay, and inside of this element you can have a description, graphical information, any other document that is attached to this file, and you can also have the items that would be inside of this service or this unit. Okay, so you can add the labors, the materials, the whatever. You can create here your own coast database. You can also import using the format BC3. Okay, BC3 as the IFC format is the standard format, the open bin format for bill of quantities. Okay, so you can send and receive information related to the price of these items using this format. Okay, for example, the Cype Archimedes. Archimedes is another software that we have in our suite to generate to project management, import and export BC3. And you can also, for example, use Archimedes to generate a BC3 from an Excel file or from any other format that is common on this industry of or this part of the project, that is the generation of bill of quantities. Okay, so here you import the items or the how can I say, single items to your own coast database. Another way would be creating a new, let's cancel that, it's just an example. It would be importing directly a BC3 file with all the information that we have in this coast database. This is very nice because here we can import both coast database itself, which means you don't have the quantities as a quantity associated to the items, or a budget or a bill of quantities that you can use as your database. So if you have a bill of quantities of your project that you made in the past, you can use this project as your database to the next project. That's quite interesting. Okay, so here I'll look for a file. I have here, I think on my desktop, a file. So it's a file with extension .bc3. Okay, I'll import that. I'll maintain, oh, I must put a name. So coast database, coast data imported today. Let's put another name. So I import that information. Let's wait a little bit, import finish it. Okay, and here I can see that this coast database have 3 chapters: sub and superstructure and internal finishes. Inside of that we have here some sub chapters, and inside of the sub chapters we have the items, and these items have materials, we have laborers, we have machinery. Okay, and we can also see these resources that are part of these items here on the section resources, and we can change. So as you can see here, this concrete, we can change the information here. Okay, so here maybe some mixed database. Part of the information is in Spanish, part in English. I'm sorry about that. Actually here I don't have a full example in English to show you, but it is actually the same. It's just the concept of the items here. Okay, when we change the information here, for example, changing the price or the code or the summary, all the items that use this labor, for example, will be updated according to this information that we have here. Okay, so this is a coast database structure. It's not, we have this situation in other softwares. It's quite common in our industry. So if you work with project management, I'm sure that you saw this kind of the kind of structure before. We have some information, some tools here to replace a code, to displace an item upwards or downwards. Okay, and also to export this information to BC3 file again if it's necessary. Okay, in my computer I have now different prices coast databases, some from Brazil, some from Spain, some of them from Thailand. Okay, so I have different coast databases here, and I can use the coast database that is most useful for the project that I'm doing. Okay, nice. I will use as example, I think this one here that I call structural elements. So here we have some information for grounding conditions, foundations, and structures. Okay, and here, as you can see, we have, for example, in structures, we have here reinforced concrete slabs, stairs, beams, columns. Okay, so beams, no, just columns. Okay, with different sections. I will use this construction database as our example. Okay, so here you can see that is everything on English, in English. Okay, so I will just maintain this selected with this icon with the keys here, and I will accept here, and I will close. So I said before, we need three things to create our view of quantities. One of them, the quantities that come from our B model. The second one, the cost, the information that is related to our price or our economic information, okay, the cost database. Now we must create a correlation between each item of our model and the items from our cost database, okay? So for that, we will use the quantities that are here, okay, sorry, the quantities not, the parameters that are here, and the information related to the identity of our elements. So for example, I could say that I would like to know how much cubic meters of IFC walls I have in this project. For that, I must calculate the first, try to identify all the IFC walls that we have on the project, multiplying to the width and then to the net side area. And to select that, I will say that are all the projects which entity is IFC wall. Okay, I will do that, for example. But I could do the same using the name, for example. All the elements which name is parapeito and not using the entity, or using the description, or using the global ID, or so we can use these properties to select the information, and these properties to quantify the element itself. Okay, so I will use this tool here, the set of measurement rows, to create these correlations. Okay, so I will open here. Actually, here it's quite similar. The appearance is quite similar to the cost database menu. The difference here is that we have more panels here, more windows. Okay, and you can create these sets of measurements once, for example, and then you can use the same sets in other projects. Or if you need to update your project, adding or changing some elements on your BIM model, you can also use these sets again. Why? Because probably the name of the families that you will introduce in your BIM models, they will probably have also always the same name. You create a criteria to name the files or name the elements that you have in your BIM model. And the same situation you have in your cost database. You probably have the same codes, the same description, and when you have to update something, you change the price, maybe change some information, but always maintaining the same code. Okay, if both informations have a criteria or a fixed criteria, when you have to create a correlation between them, this correlation can have a criteria too, and you can also adopt the same criteria into all your projects. In the future, this process of establishing a correlation will not be necessary, because you have your own library of families, BIM families or BIM objects, BIM economic information and correlations, okay, or measurement rules. Let's say that. To create that, what we need, we must create a chapter structure. For example, this set that I created before, and I called my measurement criteria. Let's edit it. I created this chapter with one structure based. It's the same structure that I will have on my view of quantities in the future. Okay, so it was just a structure with a chapter with one chapter. Sorry, a structure is too difficult, because it's a structure of chapters with one chapter that is called structure. Okay, so it's why it's too difficult to say that. So, but we can have other sets. For example, this one here called España, that we have here different chapters. Actually, these chapters they are the chapters of the view of quantities, a common view of quantities in Spain. Okay, or any other here. Okay, how we can create this chapter? If it's going to be the same structure that probably my chapter will have, I will probably have another chapter, for example, because I always use design criteria, and I can use this information to generate this chapter. Okay, so I'll create a new set, and I'll say that this is my new rules, and I can create from zero. I can create an empty chapter and create everything manually. We can import the Spanish way, the Spanish structure, or the omni-class classification that is maybe very common in some of your countries. And we can import this structure from one file. Again, one view of quantities that we created before, or a coast database that we have. So I will import this same file, the view of quantities that I have in my computer, and we can see that here we have the same structure here. Okay, substructure. Here we have the frames. We have here the floor finishes. Okay, and we can save that, and it's here. Okay, it's here. To be simple, I will use the my measurement criteria that I said before. Okay, just to simplify a little bit because it's too many information on the other example. Here inside of that, we have the structure. So the structure of our view of quantities in the future. Okay, inside of these chapters, I will start creating the rules of measurement. Okay, how we create that? We must select information from our beam model and then associate an item from our coast database. That's the point. For example, I'll delete this one, I'll delete this one. Here inside of the chapter, reinforced concrete structures, I will create a new rule that I will call slabs. Okay, for example, these slabs, I could add the name that I want here, a code. It depends on my criteria. Okay, then I will select all these slabs that I have on the project with some properties, with a common property. For example, let's create a new selection, and I will say that I will use a property. We can use these blue keys to assess the information that we have in the IFC model. So I will click here, and which parameter I would like to use to select from this IFC model: the description, the entity, the name, the code, the reference. For example, let's create a simple case here. Let's use, for example, the entity. For example, here we have a parameter that is the entity. We can have an example. For example, IFC annotation, could be IFC wall, could be IFC column, and it's part of the group base properties. Okay, so we'll use this property, this parameter, as a common information between between the inside of the IFC model that I will use to select just part of the model. Okay, how I will select that? Every time that a property that is part of the group base properties, that is a parameter called entity, is equals, or it does not equal to, or is greater than, is less than a value, I will select this information. Which value? I will click here on the blue arrow again, and once we selected the parameter entity before, inside of this list we have just we have different entities. For example, I will say that all the IFC, or maybe here, walls. Okay, so I use, for example, this case. So every time that we have an IFC wall in our model, this model will be selected, and the items that we add here on this second panel will be correlated, will be assigned to these quantities that came from the IFC walls of our model. Of course, we don't have to use every time IFC wall. We can use all the parameters that we have on the project. Sometimes we must be more precise and we will not use the IFC wall, because one IFC wall, the entity IFC wall, we have inside of this entity, we have walls with different characteristics, with different uses, with different geometry. So it's not the best way to create a model correlation. It's probably the simplest way to create that. But you can create using other conditions and other values. Okay, not just this option here. All right, so let's add here some items that in this case coming from our coast database. I'll use here the button plus. Actually, before that, I will habilitate here the database using this button here, assign codes. So here we can see the one database is the same database that we uploaded before into the project. And here in this list, we can select which database we want to use. Actually, we can combine. We can get items from one database and items from other database. For example, maybe you have a standard database from the government where you construct, but maybe this database don't have all the items that you need to your project, and you have to have your own database for some kind of items. And maybe those items that you have on the government database, you can import from that database, and your own items you can import for your own database. So you just have to select here and then navigate inside of the database and select the item. So in this case, we have a database that is called structural elements, for example. Okay, and inside of structures, as we saw before, we have a subchapter that is called reinforced concrete, and here we have, for example, some items for the concrete slab. Okay, so this concrete slab here with the materials of this reinforced concrete slab. What I have to do here? I will just have to use this button here. The first time you have to use this button here. It's the first time it's here, add. Okay, I'll do again. When we select the item inside of our codes database, pressing the button add, okay, this information, the code, the work section, the unit, the reference, and the detail line will fill this part of our item. Okay, so our item that's gonna be here. We must select between those parameters or those quantities parameters that we have on our IFC walls, which parameter of quantity we want to use to generate the takeoff of related to this reinforced concrete, which unit is cubic meters. Okay, how we will do that? We will use these formulas here. So here we can write a formula as it's the same way that we can do in Excel, for example, and here we have different cells that we can use to do that formula. For example, the cell group, I will fill with one parameter. Which parameter? We use the blue arrow. So this blue arrow is our best friend here on Open Beam Quantities. And as we selected before, let me show you here. I'll put here. As first we selected just IFC walls, and inside of the IFC walls we found just those are just the parameters, the quantities parameters of IFC walls. Here we can see just these parameters. Okay, so we cannot see all the parameters that we could have in the model, just the parameters related to the quantities of these IFC walls. Okay, so I'll use, for example, here the gross side area. And then I will add another information here that's going to be, for example, the width. So here, this 15 centimeters. And then I can say that the quantities are B that are multiplied by C. Okay, so here I have the volume of these slabs. Sorry, that's a mistake here. I used an example that it was a slab for a wall. I just saw that before. No problem. I will show you. That's interesting because I can show you how we can change these parameters now. Okay, so this correlation was created. So we add this selection to these items of our cost database. Where was the mistake? So here we have a slab and here we have a wall. We can edit this information, no problem. We will not use the IFC wall. We'll change that. Let's search for a slab. For example, we have another entity that is IFC slab. When we select that, it's okay. It's updated, no problem. Now it's okay. So the IFC slab is synchronized or is correlated to the item of reinforced concrete in slabs of our cost database. In some cases, we can have more items related to the same object or the same element of our beam model. For example, here we could have some ceramic finish that with another unit related to the same element here. It's why the units are here and not here. Okay, so you can have different multiple items related to the same selection. Okay, and you can also have the inverse situation. You can have different selections, for example, windows with different names, but that have the same window, the same glass. you can create you can extract the quantity takeoff of these glasses, just selecting, creating different a list of selections here in this area. Okay. All right. We can just take a look here because maybe the parameters are different. As you can see, look, when we change it from IFC wall to IFC slab, the parameters of quantities are different. So here we can update that. Let's see which parameters we have here. Here we have some parameters. In this case, we don't have the volume. Let me clean this information here, just to take a look at what we have here. When we change the selection, it's important, it's convenient to check the parameters. So for example, here I will select just one parameter just to be faster. But here you can create this selection. Okay. All right. Of course, we must do for everything. Okay, for every element that we wanna include in our view of quantities. Okay, so this is a lot of work to do. This is the best place to interpret it as a checklist of your process of quantities generation. Okay, so here you can create and you can check if you created or if you included or not the elements on your view of quantities. Okay, so in this case I will just accept, and this rule is created. Okay, I'll close that. So we have the three elements that are necessary to create a view of quantities. If we come here, let's see what is happening here. Oh, for example, these elements that are IFC slabs, they turn it from red to green. It means that there is a rule inside of this set of measurement rules, there is a rule that correlates this element with a item from our cost database. And we can see this item here. In some cases, we can see a list of items if it's the case. Okay, so in the end of your project, you will probably have all these symbols here, these red symbols turned into green symbols, green checks, indicating that your correlations are finished. Okay. Once you have that correlations finished, what you can do, you go from the quantities of the BIM model tab to the view of quantities tab. Okay, so actually here is the place where we will generate our view of quantities. We can create different chapters for our view of quantities. We can create this information manually. We can create without a BIM model if we don't have a BIM model, or if we have some parts of the project that are not related to a geometry or a 3D geometry. For example, imagine that you have some taxes or some or the cleaning of the building, or some information that is almost abstract. It's too difficult to correlate that with something physical. Okay, you can add it just adding this information manually. Okay, but in our case, we want to see what happened with these correlations that we created before. And here it's the best part, because you don't have to do too many things. For the first thing you have to do is use this button here, update the quantities. Why? This is a kind of safe button. Maybe here you have a lot of information, you made changes in your cost database or in your BIM model, or some person that is working with you on other software exported this file by mistake. And this button is a kind of safe button. Your prices that will be here in the cost database will be updated just after clicking this button. So I will update this model. And what should I do? What can I do here? We have two options. We can delete the data that could be here in our view of quantities, if it was the case. In this case, we don't have information, or update this view of quantities. In this case, doesn't matter, we don't have the information yet. But the most important point is which cost database is going to be your reference. In this case, my rules of measurements were created considering the structure of the cost database called structural elements. Okay, so here I will select this cost database. Imagine that in your country you have different cost databases from each region of your country, but they have the same structure, the same code, but with different prices. Here you could import these different cost databases, and here you can simulate in just one click, just pressing on this accept button, how much would cost the same building in the province A or in the region A and in the region B. Just selecting this, the origin of this, your origin of your prices. Okay, so we will select this cost database that we used before and accept, and the program is updating the quantities. Sometimes maybe I set in the general data that I'm working with euros, but sometimes we can apply here a conversion or maintain this number, maintain one here, import finished. And you see here that the bill of quantities was generated adopting the information that we have on our B model and on our cost database, and that were correlated using the set of measurement rules. Okay, so here let's just put this window a little bit here. We can see, let's minimize some information here just to have an idea in what we have here. So yeah, here we have all the informations related to this project. Actually, you can see that some of our chapters are empty because there is no set, no measurement rules to these chapters here. But this chapter, the structures, have the measurement, the rules, and we can see here from each element the quantity, okay, and the price and the result to this L10, that is the reference of this slab. Okay, so we can see that all the slabs of our project were included and their quantities were considered to generate the final quantity of reinforced concrete slab. That was this quantity with this rate, and the result, the amount, is this amount here in euros. Okay, that's the process. Okay, very easy to do when you already created your cost database and your set of measurement rules. Okay, for this element we can see the breakdown here, just clicking on that. Okay, here we have the same breakdown that was in our cost database, and in orange we can see the element that is selected here on this list. Okay, there is another point that is very interesting, that is this little button here. It's the how much of our model was let's say how it's the percentage of our view of quantities that which how can I say, which it's complicated to translate that. In this case, 100% of our view of quantities was made considering the information that come from the BIM model. Okay, sometimes we must add additional information that it was not in the BIM model, so we can do that using these tools here and add it manually. This percentage will be different if we do that. Okay, why we have this? Because when we create a view of quantities with a high percentage of information that come from the BIM model, the transference of this process of generating of view of quantities, it's more transparent. So you know from where this information is coming. So it's going to be more precise. For example, for a public project or a government project, they can ask for you for at least 9% of the information coming from the BIM model, or 9 or 85% of the cost must be related to information that is included on the BIM model. So you have this option too. Okay, here when we have a view of quantities that is more complete, we can search, we can filter by different parameters, and we can change here the currency. For example, I don't know, let's suppose that we are in Iceland. The position the decimals. Here we have different configurations, the percentages. We can also include some taxes, for example, my own tax. I will create my tax. We can add here these taxes. We can save this configuration using these buttons here and import in another project and always use the same configuration, okay? And here we can access the same cost databases that we have on the other tab. It's actually the same menu. And here on the prices menu, we can change these informations related to the prices too. Okay, so we have this option here too. We can also import and export information using the BC3 format. In this case, we are importing the chapter or the item of a view of quantities, not a cost database. So we have these icons in different parts of the program, and we use the BC3 file to different parts of the process. Okay, so in this part, we are talking about one of the parts that are in the end, that are the chapters of other project or the items of other view of quantities, okay? All right, I think that was an example. Let me see if you have any doubt about that. I know that is a lot of information, but we don't have too many time. Mohammed is commenting, the most interesting thing about it is the ability to import rules of measurements depending on needs. It's really interesting. Thank you very much, Mohammed, by your comment. Actually, that's for me, it's incredible, because we were working in a project in Brazil. That was a project for a government, and in different regions of Brazil, we must constitute the same school. And to generate the prices or the view of quantities of these schools, we just create one model and then different cost databases with the same code. And just with this option here, we can have an idea how much it would cost just changing one parameter. So it's quite interesting, this function that we have here on the program. Edna is saying, I hope in the future there are presets of measurement rules according to the countries, different countries' practices, and that users can import. Yes, Edna, that would be very nice. I think that could be very nice. Actually, OpenBeam Quantities was launched a little bit more than 1 year ago. I think in the future that's possible, and also, and sometimes we can try to find different organisms and or maybe some government departments that can also try to collaborate in a project for that, generating this set of measurements, and we could include it on our software by default. Okay. All right, so these were the comments. Just to finish it, let me show you something here that I promised before. So this model created, or these issues that were generated here on OpenBeam Model Checker were exported before. Let's open the project here on Beam Server Center. I think I closed that. Let's open it here. So I just would like to show you. I don't know if it's already synchronized. I think it's gonna be here. Let me see if my synchronizer is here. Probably, yeah. I don't have the project here. I must select the project here. Probably we will need some time to do that, to send this information to the cloud. I would like to show you exactly the same issues that we generated before on the cloud, but yeah, we must wait this uploading because it was not selected on my list. I'm sorry about that. But yeah, but you saw an example with other issues that were in the folder. Okay. There is a new release of our mobile application that's quite nice. I think probably during the next week, the Beam Server Center mobile application will have a new version. You can just update that looking in your Apple Store or Google Play, just looking for the new version of Beam Server Center. And these issues can be added in the project using your mobile phone. So if you are, for example, during the construction of the building, you've find a possibly wish issue. For example, in the field, you can take a picture of that and send this issue to the platform, and will be available on the Beam Server Center, the project issues tab. Okay, so that project that we saw before here inside of the project. Okay, so it's a quite nice tool because it's one step or one phase that is the construction of the building. So you can check in the field the building using your tablet or your mobile phone, and you can also send information from the field to the project or the team that created the project, asking, oh, this beam is in the right place, and we have a picture of that, or maybe here we have a problem. Okay, so that's quite interesting. Okay, if you don't have any other questions or comments, I think we can finish this section. It was a pleasure to be here with you, sharing a little bit about these two tools. To me, they are very, very interesting. Here on Beam Server Center, on the blogs of Beam Server Center's blog, you have this article that is 6 tools to combine with Cype architecture to enhance your workflow. You see that both of them, Open Beam Model Tracker and Open Beam Quantities, are in this list. So they're very good, or this combination between Cype architecture and these applications, it's a very good combination. Okay, so the workflow, we have much more options to work or to use our Beam models, so to other phases or steps of our project. Okay, so I will share this this link with you too, so you can take a look on that. Okay, I hope I see you in a next opportunity and a next video or in the next webinar. Once again, it was a pleasure, and see you again soon.